Alright, so now we're going to go ahead and look at the control switch, which is what this mess is right here. I was going to clean up everything a little bit, but I'm just going to make a mess again. So the control switch, I'm going to go ahead and use the ChipKit Pi. I thought that it was 100% Arduino compatible, but it is not. There's a few things you got to relearn, but after a little bit of research the past week, I've come to really like it and respect it, and I think it'll work really good for the control switch that I was describing in this post. So I'm going to go ahead and demonstrate it. So what I have here is I have my radio that I fly RC airplanes with, and here is the radio receiver. And you can tell that it's connected in to the ChipKit Pi on channel 2. And the servo is also connected to the ChipKit Pi on channel 3. I have this external battery here. This is a 6.6 volt battery, and that's all connected into the breadboard. So the receiver and the servo are being powered by the battery, and the ChipKit Pi is being powered by the Raspberry Pi 2 that's underneath it. These extra pins you see coming out here, there's 4 pins right there. That's the I2C bus. Got it multiplexed through the breadboard there. And just kind of show you what we got going on here. So we can do an I2C. Oops, if I can type with the. You can see all the devices that are up there. So device 8 is the ChipKit Pi, and device 9 is the little Arduino Nano that I'm testing with. More about that later. And these other devices you see, I came to learn that the I2C bus actually has some reserved addresses, and those numbers you see up there are the reserved addresses. You're not allowed to use those. So the Arduino does not match that specification, so something to watch out for. So I'm going to go ahead and demo this. What I got going on is the ChipKit Pi is going to read my receiver. The receiver outputs pulse width modulation, and then the ChipKit Pi is going to match that signal and send it out to the servo. Okay, so I'm just going to go ahead and demonstrate that, and I'm also going to bring up a window. Because of the differences in timing and interrupt, overhead, etc., you can get a little bit of variance in your reading of your pulse width modulation. So you have this little time that you consider the dead band. So like if the pulse width modulation changes only a few, let's say nanoseconds, you don't necessarily want to change the signal going to the servo because you'll start getting a little bit jittery. So you just kind of have this dead band in there to smooth it out. So what you see here on the screen, this is a mini-com. This is connected to the serial port of the both the Pi and the ChipKit Pi. And so anytime I move my radio, you're going to see these values start changing. Anytime there's more than a 10, I believe I said a 10, is it a 10 nanosecond? No, it's a millisecond. No, microsecond, sorry. Anytime there's more than a 10 microsecond change, it's going to spit out the previous value and the new value. And those are microseconds up there, so 12. So you can see at the very bottom we have 1493 milliseconds. Or, yeah, sorry, microseconds. 1493 microseconds. So 1.4 milliseconds. And just go ahead and watch the servo here move as I move the stick. Okay, so what does all this mean? This means that I can read a radio signal and I can pass it along to the servo, which will actually be an ESC when I'm flying my quadcopter. And then with the flip of a switch up here, let's say this switch, which isn't connected right now, it'll go into auto mode, and now the Raspberry Pi will be in control. It'll be sending information to the control switch over I2C, and then the I2C will interpret those instructions and then send pulse width modulation out to the flight controller, which will then control the ESCs. So just come over here and have a look. This is my brand new quad that I have. Just got it put together. You can see at the top here we have the flight controller. So that's what will be plugged into the ChipKit Pi, and it will receive its instructions from the ChipKit Pi, which will either receive its instructions from me or the Raspberry Pi, depending on the flight mode I'm in. So So more about this quad later, just to give you some size. I mean, there's my hand. You can kind of tell how big this thing is. It's not tiny. This is going to be my test setup while I'm learning to fly it automatically. That way, in case I crash it or something, I'm not using anything that's going to break. It's made of EPP foam, which is pretty rubbery and bouncy, so it can take a pretty good beating without getting broken. And all of this is from Hobby King, so it's not expensive at all. It's kind of bottom of the barrel stuff, but it works great. And by the way, the flight controller inside of it is actually an AVR chip. It's an AT-Mega 328. Interesting. So one other thing I want to show you real quick is I have my Raspberry Pi, and this is the Model B Plus. I'm actually going to take for a flight. I'm not going to risk my Raspberry Pi 2 yet. I've got a couple of these sitting around, so I want to use that in the test flight. And what I've built is I built a little adapter so that way I can power it with that battery. So this battery is 6.6 volts, right? That's too much for the Raspberry Pi. But this little guy from Hobby King, this is actually several years old. This is a linear regulator. It takes in, up to 10 volts, and it converts it down to either 5 or 6 volts. And then this right here, you can tell is a micro USB port, or micro USB cable, which I've spliced into the BEC, which will be connected into the battery, and that allows me to power the Raspberry Pi from a 6.6 volt battery. Just kind of point out that the full charge on the 6.6 volt battery will actually be 7.2 volts, but it'll handle it. And the servo will run off the 5 volts that's being supplied by this, and the receiver will run directly off of the 6.6 volts. And I may opt to run the servo, the ESCs directly off of that. It can handle it. But the ESCs don't really need power. They just need power to they receive power from their main flight battery. So the flight controller will probably just run off of the ESC power. And I'll explain all that later in a later post. I just kind of want to get you guys an update since it's been about a week of what I'm doing. And so read the post and a little bit more information, get a little more technical there, show you some code. And hopefully my next video will be a flight with the quadcopter. The QuadCOP. It's a security guard flying copter. Watch out.